Have you ever wondered how a small group of amateur radio operators from California, working in their basements, got the approval to go to space? Worry no more. I will answer those questions and more. Good morning, everybody, and welcome to HRU 2023. It's good to have you all here. I know it's early in the morning in some places, but we're going to talk about amateur radio satellites in space from around the world to around the corner. Welcome, everybody. Thank you so much for participating in the 24th year of Ham Radio University. Phil N2MUN, our founder, who passed in 2022, much too early, is smiling right now. Okay, we have a lot to cover. So let's light this candle and get ready to go. We have liftoff of the Thor DM-21 Agena B at 2040 UTC on December 12th, 1961. Where were you then? Maybe a lot of you weren't even born. Carrying the first amateur radio satellite, Oscar 1, as a secondary payload for the surveillance satellite, they didn't know it at the time, a spy satellite, 9029. Stand by. It's now reported that Oscar 1 is in orbit, and these are the first sounds from space that amateur radio enthusiasts hear. Some might say, what is that strange sound? Well, to an amateur radio satellite operator in 1961, that CW message was music to their ears. It's Oscar 1 transmitting its hi message. Did it. H-I. You learned a little code here. I'm W2JV, Whiskey 2 Juliet Victor, Peter Portanova. I've been a ham since 1964. I was introduced to the amateur satellites in 2008 at Field Day with none other than Neil Heft, our organizer today. Thank you, Neil. I'm forever indebted to you, or as my wife would say, don't mention that name around here. After thousands of contacts through the amateur satellites in space and hundreds of presentations, I still get those goosebumps in the back of my neck, pointing my antenna at a 10 centimeter by 10 centimeter CubeSat, traveling at 17,000 miles an hour. Here's the CubeSat. Here's a model of AO85. This is an actual size of AO85. So pointing the antenna at a moving target 17,000 miles an hour is not easy, but it's not that difficult either. And then, of course, making the contact could be in a LEO orbit or MEO orbit from 400 to 3,700 miles in space. A lot of you are saying, what? There's no such thing as making contact with a satellite at 3,700 miles in space. We don't have one like that. Well, I'll show you later on. Stay tuned. Don't go away. And I showed you replica again. Here it is, AO85, the first CubeSat that we launched. And we're going to talk about Tony Montero and his contributions to this later on. I guess my teachers were right when they said, Peter, your mind is always in space. In my past presentations for HRU and others, I spoke about how to operate the FM satellites. Those forums can be found on the HRU YouTube page, which has a lot of great content, or my YouTube channel, W2JV, or my QRZ page. Today, please forgive me, I want to take a step back in time and talk about how the amateur community got into space. What is an amateur satellite? How you can get started as a satellite operator, and the evolution from the first basic satellite to a few noteworthy satellites that have been launched. I can't go through all of them, it would take hours, but we'll go through some of the key ones that I selected. I really enjoyed doing this research because it taught me a lot that I didn't know about the early satellites before I was involved. Well, since 1961, you got your pencil and paper ready? Well, I hope so. There have been approximately 115 amateur satellites launched. AMSAT has been directly involved with 25 amateur radio satellite projects, 19 of which were successfully placed in orbit. You know, getting into space is not easy. It's easier now than it was back in the 60s, 70s, and 80s, but it's still not easy at all. Today, we have 21 active amateur satellites orbiting. So no complaints, there's always something up there for you, 4 of which are from AMSAT North America. Remember, satellites is a world game. It's not only AMSAT North America, the entire world is launching satellites. And unfortunately, we at AMSAT North America have some restrictions here, what we can do, what we can build, who we can deal with. Other countries don't have those restrictions, and other countries also have some free rides that are available to larger orbits. So it's a world game. Don't think of it just as AMSAT North America, although we're doing our best. So where did this audacious idea originate, that amateur radio operators could actually build a satellite and get approval to have it ride to space? Sounds crazy, doesn't it? Well, credit for planting that seed became Project Oscar. And that goes to Don Stoner, Whiskey 6 Tango November Sierra, reporting on a solar-powered repeater in his column in the April 1959 issue of CQ magazine. Anybody have that copy? No, I don't either. Don speculated, can anyone come up, he speculated, with a spare rocket for orbiting purposes? Just threw that out. This tiny spark ignited the imagination of Fred Hicks, W2JV, who knew something about rockets. He and Chuck Towns, K6LFH, who eventually became chairman of Project Oscar, I'll tell you what Oscar's all about, decided that not only was it worth a try, they were in the best position to work with Don to make it happen. So they did. Now, Lance Ginner, K6GSJ, was another key player in getting Oscar 1 off the ground. And, you know, unfortunately, Lance is one of the few surviving members of Project Oscar. And he spoke at a symposium very eloquently about his role. Here he is at 21 years old. Now, do you notice the white glove treatment carrying Oscar 1? Can you imagine? He'd be sent to satellite jail. But there he was, carrying not a prototype, the actual satellite. I guess he was taking it to the launch pad. It's that casual back then. He was 21 years old. He was a technician in 1960, working at Lockheed Missiles and Space Company in California. And he was in the Agena A and B space vehicle checkout complex. That's important because at this time, he became aware of Project Oscar through Chuck Towns. Hams at Lockheed introduced Ginner to the concept of attaching a small satellite to the Agena A spacecraft that Lockheed was building for the Air Force. That really intrigued me, Ginner said. And I was right in the test area where we tested the Agena. How perfect can that be? That's when I got involved. That involvement, including more than helping design and build what would become Oscar 1, it was a plunge into the deep end of national security politics. We know a little bit about national security politics, don't we, over the last few days? Well, just getting a ride was all political, Ginner said. There were huge conversations that were beyond me at the time when I was 21 years old. The Hams wanted to attach a civilian-made satellite, listen, to a United States Air Force spacecraft flying a classified reconnaissance mission. It was never done before by a bunch of amateurs. Let's think about that. Can you imagine anything close to that happening today? Flying an amateur satellite on a secret mission? It took some heavyweight people to make that happen. Like Republican Senator Barry Goldwater, oh, do we miss him? And General Curtis LeMay, Chief of Staff of the Air Force. Silent applause for those folks. It was a big leap for the Air Force to let us hop onto their mission, Ginner says. No question about that. That's an understatement. So we started building the satellite before we actually had permission. Ginner and his fellow ham enthusiasts, that's him there. Look at the Heathkit radios behind him. All kits, of course. They dubbed their satellite, here we go, Orbiting Satellite Carrying Amateur Radio, or Oscar. When I started looking for Oscar back before I was involved with satellites, all I kept getting was the Academy Awards, the Academy Awards. So finally, I got the notice, put amateur Oscar and you'll get it. Now, the group of hams building it in their garages and spare time call themselves Project Oscar. That makes sense, which was formed in 1960. So when permission was given to allow Oscar 1 to fly, the Air Force just had one requirement. Just one requirement? The satellite had to be the exact weight and size fit that would normally contain the ballast. Now we can see that here to the right of the green arrow. There it is. That's a blurry picture of Oscar 1 sitting on that rocket. Now the shape that Oscar was built looked like the ballast it replaced, exactly like it. So now here's a closer look at the previous slide. Okay, there we go. There is a good look. By the way, I've never seen this picture before I started to research this project. It just gave me goosebumps when I saw there's Oscar 1 mounted. How could it do that? So Oscar 1 was a quasi-rectangular box. It was about 12 by 12 by 12 inches, primarily made of magnesium, with a mass of approximately 10 pounds. So taking a closer look at Oscar 1 on the bench, the two approximately square surfaces were slightly concentric, slightly curved, but were concentric with each other. One was slightly smaller than the other, a monopole transmitting antenna. There we go, monopole, about 60 centimeters long, extended from the center of the convex surface of the larger square. Reflective striping was applied for temperature control. Can you imagine that? They got some knowledge from Lockheed. It contained a radio transmitter and a keying circuit, which would generate and transmit the word high in Morse code. Let's practice that again. Dit, H, dit, high, the international signal. You just learned again 2 more letters. Congratulations, folks. There was also a pair of thermistors and a timer. The timer was connected to the thermistors to control the pace at which the high signal was sent based on the temperature. So we're dealing with the first science application to an amateur satellite. Power was provided by 3 18-volt mercury batteries. That's what we had. They were wired in parallel. The interior of the satellite was filled with a foam-like substance to protect the components. There was no propulsion or attitude systems on the satellite, nor was there any rule that there had to be, which changed now. The Oscar team had to keep in mind something very important, that ejectable satellites were never done before. Now get this, ejectable satellites were never done before. So what do? A premature release of the Oscar satellite would keep the Agena satellite from deploying its booster and end the mission, a catastrophe, not only for the Air Force, but also for amateur radio. The door would never, ever open again. You talk about really pressure. So the Oscar team designed a very sophisticated ejection system to release Oscar 1 into space. Are we ready for that? There it is. There it is, a $3 spring from Sears Roebuck. Do I hear collective laughter? I know I did when I saw it. There's the release, the green arrow is the release, and there's the spring. So the total out-of-pocket costs of Oscar 1, anyone want to take a guess? Nope, you're too high, much too high, $68. $68. In early December 1961, a United States Air Force rocket took off from Vandenberg Air Force Base in California, carrying a very special payload. The main payload was a Corona surveillance satellite, but tucked just after the satellite was a tiny package of electronics stuffed into something that looked like a slice of cake. Oscar 1 was received by 570 hams in 20 countries for 20 days. Now get this, a mere 4 years after Sputnik. If that's not remarkable, I don't know what is. I really don't know what is. I think we should give a round of applause. Yes, a round of applause. Thank you. Oscar 1 deserved that. That's for sure. No question about that. Another noteworthy satellite built by Oscar was Oscar 3. Yep, we'll applaud again anytime. Okay. Now the team wanted to do something different. So the first 2 satellites were beacon satellites. Just sent the beacon out. They said we need to continue to grow. So the 3rd satellite launched by Project Oscar launched in 1965. It was the first satellite to carry a linear transponder. Linear transponder. You could speak through it. A ham could go up and down. It operated for 18 days in which 1,000 amateurs in 18 countries were heard operating through it. Phenomenal. Oscar 3. Just a great moment. So let's now continue to 1965. So the government, now this is this is interesting. Listen carefully, don't leave. The government was testing the Titan 3C, a huge booster. Newspapers picked up that they were using sand as ballast to test lift capability, which was perfectly within regulations. However, the government found out it was not even Florida sand and was imported from somewhere else, which was, the least to say, very embarrassing. So the Air Force, responding to that criticism, within less than a year, issued a call. Anyone want to fly a geostationary orbit? No size or weight constraints. Now, are you kidding me? I repeat that. We're going to fly you to a geostationary orbit free, no size or weight constraints. That's crazy. Unfortunately, that does not happen anymore. So the Project Oscar team said, sure, that's their style, plunging right into it. However, one little problem. They never built a satellite for a geo orbit or the knowledge to build a complex satellite like that to get to a geo orbit. LEO orbits are one thing, but getting to a geostationary, it's a whole nother set of engineering. So the team got in touch with the TRW Radio Club in California. TRW had a program called VELA, V-E-L-A, and a few of the members worked on that particular project, which was a nuclear detection satellite. That satellite was put in a HEO orbit. So the team at TRW knew how to build a satellite to get to a high orbit. So the TRW club said, yes, we can take that challenge. And boy, what a challenge. Oscar 4 was launched December 21st, 1965. Where were you? I was in high school. By a Titan 3C launcher, that huge launcher from Cape Canaveral. The first time they did it. Oscar 4 was launched piggyback with 3 United States Air Force satellites. Oscar 4 was the 4th radio satellite launched by Project Oscar, the 4th one, and the first targeted for a geostationary orbit. How about that? I lose my breath when I say that word because that is the mega geostationary orbit. So Oscar 4 was launched, and here we go, start a complex of problems. It was launched 1 second behind schedule. From an initial parking orbit of 194 kilometers, the Titan's trans stage boosted the package into a transfer orbit, pending a final burn to circularize its orbit. However, the final burn scheduled 6 seconds after liftoff never occurred due to a leaking valve in the booster's attitude control system. Oh boy. Oscar 4 was released from the trans stage much later than intended, likely by the booster's backup timer, we think, and stayed in this geo-transfer orbit. The elliptical orbit caused Oscar to pass through the Van Allen radiation belt, not once, but 5 times in each 24-hour period. No provision had been made to cope with the effects of radiation on the solar cells or other components. Because of these unexpected complications, the life of Oscar 4 was short and the operation marginal. The satellite, however, remained in operation for 85 days until 1966. And hams did operate through it. It re-entered Earth's atmosphere April 1976. So it orbited around until it lost its kinetic energy. Do I hear a collective cry? Yeah, people tell me that was just, even though it was diminished, it still was a wonderful satellite. So the Project Oscar team saw a shift at that point from the military to NASA now scheduling flights where they had no connections at all. As a result, they had not flown an aperture satellite since 1965, Oscar 4. So now on to the next chapter. And the next chapter is AMSAT, the Radio Amateur Satellite Corporation. What happened? Well, in 1969, George Jacobs, the CQ magazine propagation column writer, W2JV, who also was the PR rep for the original Project Oscar team. So he was deeply involved from the beginning, and he was in DC. So he helped with the connections with the different people that needed to give the approval. So he was invited to speak at the Cubesat Amateur Radio Club. He spoke of the need to keep amateur radio in space. Got to do that, and suggested forming a group in Washington. Perry Klein, good old Perry Klein, W3PK. And by the way, you're looking back there at A07. I'm going to give you a little preview. That is a model of A07. It was delivered to me from Perry Klein after I spent some time in Washington at a symposium in his van. So that traveled in Perry Klein's van. I'm pretty sure that was the case. So he was in the audience. Sorry for that interruption. He took the suggestion, and within 2 weeks, he formed AMSAT, the Radio Amateur Satellite Corporation, this newly formed group with 1 paid employee. Later on, Martha, that was a later time, began to think about building a satellite, and with their connections now with NASA, felt confident, very confident they could get a launch. So George Jacobs suggested finishing Oscar 5, which was in a warehouse just collecting dust on the West Coast, and have Oscar 5 shipped to the East Coast for final conditioning. So after some modifications, there she is, by AMSAT members, again working mostly in their basements and garages, Oscar 5, later to be called Australia's Oscar 5, or simply AO5, was successfully launched on a National Aeronautics and Space Administration, NASA vehicle. Previous Oscars all had been launched, as I said earlier, using US Air Force rockets. The Oscar 5 satellite performed nearly flawlessly. Australia's Oscar 5 was launched January 23rd, 1970, no more big sounds, by a Thor Delta launcher, very reliable, from Vandenberg Air Force Base in California in a geocentric orbit. So this was the first satellite to be remotely controlled. It was built by students at the University of Melbourne, Victoria, Australia. Battery powered Australia's Oscar 5 transmitted telemetry on both 2 meters and 50 milliwatts and 10 meters and 250 milliwatt bands. It operated for 23 and 46 days, respectively. Passive magnetic attitude stabilization was performed by carrying 2 bar magnets, pretty brilliant, to align with the Earth's magnetic field in order to provide a favorable antenna footprint. The University of Melbourne compiled tracking reports from hundreds of stations in 27 countries. The satellite is still orbiting, but non-operational. Still orbiting, but non-operational. Batteries failed and no solar panels to pick that up. Now on to my favorite satellite. There it is, AO7. Now back here, let me get out of the picture. There you go. Okay, back there is a full-size replica of AO7. It was built by my friend George, K2KVI. What a wonderful job at doing it. I mean, so wonderful that they wanted to have it in Washington at the Oscar Park facility. It was sent to Washington, as I said, for AMSAT's 50th anniversary in 2019. AO7 is the oldest amateur radio satellite still in operation. The oldest satellite still, let me get a little more light here. Now it's in my eyes, in operation. AMSAT Oscar 7, you don't want to see me anyway. AMSAT Oscar 7 was launched November 15th, 1974 from Vandenberg Air Force Base. AO7 was launched piggyback with 2 other satellites. It was released in a high LEO orbit. And as a result, a larger footprint, meaning coverage to Europe and South America, was possible. So similar to AO6, AO7 was built by a multinational German, Canadian, United States, and Australian team of radio amateurs under the direction of AMSAT North America. The spacecraft is solar powered, weighs 65 pounds, and had a 3-year anticipated lifetime. 3-year anticipated lifetime, launched in 1964. But it far outlived that expectation. So don't we wish that all for ourselves? Now, here's for the bad news, but it's going to get better. AO7 became non-operational in mid-1981 due to a battery failure. After being declared inactive, AO7 miraculously sprung back to life and was first detected by Pat Gowan, G3 IOR, on June 21st, 2002. Imagine, battery failure 81, 2002, Pat picked up beacon signals from AO7. In early 2002, what happened? You can't be 100% sure. We can't send a repair person up there, but what we believe from the analysis, one of the shorted batteries became an open circuit, and now the spacecraft is able to run off its many solar panels. So for this reason, it's not usable in eclipse and may not be able to supply enough power to the transmitter to keep from frequency modulating the signal, which happens often. So when it's continuously eliminated, the mode will alternate from mode A to mode B. Mode B is on the 10-meter side. Mode A is VHF, UHF, every 24 hours. So one of my thrills is speaking with amateur operators in Europe through AO7 on either sideband or CW. It's a noisy frequency drifting transponder, but with a weak signal, but a wonderful experience. Let me just give you a little clue about that, just a little clue. These are people, this is a special grid. People are trying to reach this grid. We have 488 grids in the United States. You can see it's noisy. The signals are wobbly. Don't know if you can hear that. November 8 Radio Oscar. He's happy. A lot of people there on the satellite. A lot of people. All right, that gives you a little idea of the hecticness of operating. Excuse me. Let me have a little bit of spotted tea here. Just honey in the tea, nothing more, just honey. Anyway, from an earlier slide, we discussed Oscar 4, which was launched in 1965, the first attempt to put a satellite in a geostationary orbit. For the next slide, I'll talk about 3 satellites that reached a high orbit: AMSAT Oscar 10, AMSAT Oscar 13, and AMSAT Oscar AO40. Now I'm going to refer to the next class of satellites as phases, which is a design term. Phase 1 was Oscar 1 through Oscar 4, designed for low Earth orbit. Phase 2, Oscar 6, Oscar 7, back here, there, Oscar 7, was designed for a higher than intended LEO orbit, which makes it very exciting to work Europe. Phase 3 are intended for a highly elliptical or Molina orbit, M-O-L-N-I-Y-A, for those that are counting. So Oscars 10, 13, and 40, the holy grail of orbits, is phase 4, or geosynchronous orbit, parked at 22,000 miles above the Earth. In 1980, AMSAT built a phase 3A. You don't see it here, and I'll tell you why. It was intended for a geostationary orbit. Unfortunately, there was an Ariane 1 launch failure. After the loss, with sympathy and empathy from the space community, Oscar 10 was built in just 3 years. Launched in 1983 in a highly desirable Molina orbit. Well, here we go again. After separation from Ariane 1, a control error on the rocket caused it to collide with the final stage. I told you, getting to space isn't easy. The collision also indirectly affected the propulsion system. So not only was the inclination 26 degrees could be achieved, and now 57 is desired for a proper orbit to allow coverage of the polar regions, the memory chips were also delivered faulty. How bad can it get? As a result, the high radiation exposure in a limited elliptical orbit, the scientists forecasted it to fail within 3 years, which they did. So Oscar 13 launched in 1988. Let's talk about a new one. This was the most trouble-free satellite in a high orbit, enjoyed by amateur operators around the world. However, due to the differential pull of the sun and the moon, Oscar 13 orbit eccentricity, that's its deviation from a circular orbit, I think, began to increase in 1994. As a result, the perigee height and atmospheric drag started to rob the satellite of kinetic energy. The speed changes. It re-entered Earth's atmosphere in 1996, but it worked so well and people really added to their satellite DXCC count. The next satellite of interest is AO40, which was a high and a low period for AMSAT. And we'll continue the slide deck. The satellite was launched on 16 November 2000 as a secondary payload on an Ariane 5 launch vehicle, and reported cost was $4.5 million. The satellite was intended to be in a Molina orbit. You can see where the story is going, can't you? The Molina orbit, great orbit, combines high inclination, 63.4. Remember I said 57 is good? 63.4 is better, with a high eccentricity. Again, with a high eccentricity, 0.722, to maximize footprint time over time. So that really is nice dwell time. And it maintains that over high latitudes. Each orbit lasts 12 hours with an apogee of 64,000 kilometers. I can see a lot of sick days when this was up. And the perigee between 4,000 and 10,000 kilometers. That sounds exciting, doesn't it? However, here's the rest of the story. Unfortunately, oh boy, due to an explosion caused by pressure in the propellant pipes, caused by a malfunction of the control valves, the loss of the motor caused AO40 to be left in an equatorial orbit, an orbit that the satellite was not designed for. The orbit at apogee was 22,000 kilometers, but at perigee, a screaming 800 kilometers at perigee. Just think about that differential. As a result, instead of a 19-hour communication window, it was only 9 hours. It was operational until March 2004, when a final failure of the satellite occurred. Oh boy. Oh, take a breath. Are you still with me? Okay, good. I'm glad. Thank you. Thanks for your patience. AO40, I can't get excited about this stuff. It's nutty. AO40 was AMSAT's last attempt to build a high orbit satellite. Why, you say? Well, high costs, technology demands, and arms regulations limiting our ability to collaborate with other countries. So AMSAT decided, in order to keep amateur satellites in space from the North American side of the world, to adopt a more attainable method, and that is the Cubesat. Why is that man smiling? Well, he should be smiling. It's all started with these two folks. The first Cubesat concept, I love that smile, was developed by, who says engineers don't smile? Was developed by Professors Jordi Puig-Suari and Bob Twiggs from California Polytechnic State University and Stanford University. Where else? The idea was to provide students with an affordable, hands-on experience in space exploration. Man, what a brilliant idea, no doubt about it. A low Earth orbit cube that has a theoretical life of 25 years to stay in orbit. However, for two-way communication purposes, it's dependent on battery management, which can shorten its life to 5 years. Now, the new generation of CubeSats, like AO91, can lose battery power, but switch over to its solar cells to maintain communication. However, you can only access the satellite during sunlit orbits. And AO91 is an FM satellite, which means that with 2 radios, you can have a ball with it very inexpensively. But we'll get to that later, not too much later. 2003 was the first launch. So on June 30th, 2003, 6 CubeSats were launched into a sun synchronous orbit, great orbit of 820 kilometers. One of the CubeSats, not bad news. QuakeSat was a project by Stanford University. To date, this is where it gets complicated. Oh boy, more than 2,000 CubeSats have been launched into space. More than 2,000 CubeSats, and growing every hour, have been launched into space by 50 countries and growing exponentially every day, exponentially. And what's the problem? You're right, space debris. It's a major concern. Space debris is big. For that reason, the FCC has a new orbital debris mitigation ruling, which is a new challenge for AMSAT. Okay, so what is a 1U CubeSat? So here's my 1U CubeSat. There it goes, flying by. That's my 1U CubeSat. There it is, again, still alive. So what is a 1U CubeSat? Let's talk about that. There it is. Okay, it's a 10 centimeter by 10 centimeter by 10 centimeter, 3 tens, cube, and weighs 1 kilogram, roughly the size of a Rubik's Cube. Well, we don't have to look at a Rubik's Cube. We actually have the satellite right here. There it is. Anyway, the electrical power system, EPS, consists of solar panels, IHU, International Housekeeping Unit, and batteries, internal, not international. That's another world. Internal. And batteries. Solar panels hold solar cells that convert solar light from the sun to electricity. So AMSAT recognized the potential, no kidding, and affordability of using the CubeSat technology to keep amateur radio in space. NASA, in conjunction with this, developed the Alana program, educational launch of a nanosatellite to further STEM initiatives, science, technology, engineering, and math, to partner with universities and other schools to obtain a free launch if the CubeSat had educational potential. So AMSAT, what they do is they partner with universities to build a CubeSat with science provided by the school, and AMSAT adds an amateur radio transponder. And if approved by NASA, AMSAT gets a free ride to a LEO orbit. So AO85, Fox 1A as originally called, was commissioned as AO85 was the first of AMSAT's Fox 1 1U, which is the CubeSat in its size designation, launched as part of the NASA Alana X11 12 grant on October 8th, 2015 from Vandenberg Air Force Base in California. Another major contributor, there it is, another major contributor, as I said earlier, was Tony Montero. And Neil knew Tony pretty well, AA2TX, AMSAT's Vice President of Engineering, who played a significant role in space-based hardware development. What a brilliant man. He also led the engineering team to gain acceptance to the NASA Alana program. He passed at the very early age of cancer at 55. So as an homage to him, his daughter, her voice, Veronica, was recorded on AO85 and was heard when the satellite was in safe mode. What a man, what a wonderful man. May he rest in peace, Tony Montero. So what is an amateur satellite in space? Been talking a lot about this, but what is it? Well, essentially, not too bad. There are 3 basic types of operations on satellites: FM satellites, linear transponders, beacon telemetry, and digital repeater satellites that messages can be passed through the satellite. Now, the FM satellites are basically, the FM ones, are cross-band repeaters. You might, for example, transmit on a frequency called the uplink in the 2-meter frequency and receive from the satellite in space in LEO orbit called a downlink to the 70 centimeter band, similar to a terrestrial repeater, and only one signal like that and a terrestrial at a time is recognized. It's a challenge to communicate with during the satellite's busy periods. Now, the linear satellites, sideband or CW, have a larger passband, allowing many operators to access the satellite at the same time. It's easier, obviously, to get a communication through it, but a little more expensive, just a little more to own the equipment. But believe me, and you can believe me, it's well worth the experience. The satellites are still built by volunteers and used by licensed amateur radio operators. All you need is a technician license, easy peasy, technician license. That's all that's required to get your radio off the ground of terrestrial repeaters and into space. So we spoke earlier about the different orbits. So we have a number of different orbits. For a LEO orbit after launch, it flies in a low Earth orbit from 250 to 2,000 kilometers, and the orbit can be between 90 to 120 minutes, depending on its orbital attitude. So you can see the LEO orbit hugging the Earth, right close to the Earth. It's flying very close to the Earth. The International Space Station, yes, it's a satellite, takes about 90 minutes to complete one orbit around the Earth. IO-117, formerly known as Green Cube, flies in a medium Earth orbit. Now look at that. Look at this. Look at the footprint. Look at the difference between the ISS or AO-91, 92 versus that MEO orbit. And you can see the larger footprint. What does that mean? More land coverage and is a digipeater. What is a digipeater? I can send my 1200 baud packet signal 5,800 kilometers in space, 5,800 kilometers, and receive back a confirmation from a ham in Italy, in Spain, or South America, depending on the footprint of the pass. A real opportunity to add to your DXCC count. So the Green Cube digipeater, there it is, launched. It's a 3U, larger now, or a 4-inch by 4-inch by 13-inch CubeSat. Now, what has it done? It's aimed at demonstrating an autonomous biological laboratory for plants cultivation on board a CubeSat platform. The project is coordinated by the Italian Space Agency, ASI, and it's benefited of a launch opportunity offered by the European Space Agency. Believe a free launch. I told you it's a world game. The spacecraft was launched on board the maiden Vega C flight on 13 July 2022 and has been deployed, as we said, in a medium Earth orbit, MEO, at approximately 5,800 kilometers. It has a store and forward digipeater, which can be accessed by amateur radio operators, and has a dwell time of 1 hour. Dwell time meaning that satellite will stay over in my footprint for 1 hour. So here is an example of my activity on IO-117. Now, this chart is an example of the telemetry. So telemetry is received. It is then translated into call sign digitally. So there's an example that's been decoded. In yellow are the stations that are calling me. EA4 is in Spain. IW7 is in Italy. Isn't that interesting? Now, are you interested? How can you not be? Come on now. I hope you are. I really hope you are, because the satellites are waiting for you. This is your choice. You can start with what I call the KISS method. Keep it simple, FM satellites, and build from there. So that's it. I mean, and this is what's available. 17 satellites are available, 10 linear, 7 FM, 9 telemetry. And the FM and telemetry satellites linear every month or so, they're always adding to it. So as many satellite operators have said, you probably have most of the equipment needed, except maybe, a handheld Yagi antenna. There I go. I can't stop myself, but I will. So as many operators, they said, yeah, you have most of the equipment, except maybe a handheld Yagi. All you need to know, are my HTs capable of receiving VHF, UHF frequencies? Do I have an ELK or ARRW Yagi antenna for transmitting? What is my grid square to determine when a satellite will be in my footprint? What is the compass track of the satellite to follow? And is the pass high enough to receive the signal? That's about it. So you can start practicing with the International Space Station when the crossband repeater is active by listening to a few passes. And all you need basically is maybe a little longer than your HT antenna it came with, a little longer antenna, and there are a few out there that are available. So you listen to a few passes to get to the hang of it. So again, as I said, all you need to talk through it is a technician class license. So let me give you an example here of what's going on. Again, very inexpensive to get into space. So I'm going to repeat that. 2 expensive HTs with a VHF and UH capability, a Yagi antenna if you want to transmit like an arrow and elk. And after viewing a few YouTube videos, seeing a few mine, seeing a few of the great people out there that put them together, you'll really become excited, I hope. Get the bug. Okay, here is a pass that I made when I was WB2OQQ. And you can see I'm talking right now through the AO51 satellite. I'm only using 1 HT, which can get you started. W2OQQ handheld. You'll notice, he hears me now. You notice how I'm tracking the satellite, how I'm positioning the antenna for the best signal and adjusting frequency changes due to the satellite traveling through space at 17,000 miles an hour, otherwise called the Doppler effect. Kilo Baker Henry, thank you. WB2OQQ, FN30 handheld. It sounds difficult, but it really isn't. If you have the right location, the right set of circumstances, the right height, it's really not too difficult to do. So, are you ready? Are you ready to get into space without getting airsick? Again, there's what you need. Dual band radio, FM satellites are available, or prediction software, and go to the AMSAT site, www.amsat.org, and you will really get everything you need. Well, I really hope this forum has given you an appreciation of the effort amateurs have gone through to put amateur radio in space. And I hope this talk has ignited maybe a little spark in you to consider using your HT to become an amateur satellite operator. And other satellite operators will really help you a lot. And you can join the AMSAT bulletin board at amsat.org. That's bb@amsat.org, and ask as many questions as you can. Really would be a pleasure. So that's it. Join AMSAT. Thank you for attending the forum. And the HRU team continues to represent the ideals that our departed founder, N2MUN, Phil, instilled in all of us. And to our audience, well, thank you so much. We appreciate your support. Thank you for supporting HRU for 24 years. Thanks to our chairman, Tom, KA2D, done a phenomenal job, and along with the team. Keep looking up, and I hope to exchange my grid with yours very soon on the amateur satellites in the near future. Well, this is the first time that I've done this presentation. I don't think it's done too many times before, and hopefully I didn't lose too many people along the way. Hope you enjoyed it. Thanks a lot, and if anybody has any questions, Neil, I'm ready for them.
Okay, we don't have any questions, but we do have 2 comments. The first one is wonderful presentation, and you are such a passionate speaker. Thank you so much for sharing this history, Peter. I am just starting my journey into the SAT, 73. And then another person came in and just said thank you. So,
well, thank you, guys. I'll certainly ask Neil. I'll ask Tom for a bonus. But thank you guys very much. Yes. It certainly has gotten me excited, and Neil has, as I said earlier, Neil and the team, and Tony, who also passed away too soon, really showed how exciting and fun it could be. Thank you again, Neil, for all the help to get me into space.
Okay, very good.
Again, if you have any questions, you certainly can reach me at W2JV@amsat.org. It'd be my pleasure to help you in any way at all. Clearly, my goal is to get you into space, and this was sort of a primer so you can have a little appreciation of what it took to get launched. Thanks, everybody, and 73s for now, and enjoy the rest of the forums. They're really great ones here on Ham Radio University. Thanks a lot, Neil. See you guys, 73s.
Bye-bye.